My name is John Garrett, and this is my tech demo 2 for multivariable calculus. The first thing that we are tasked to do with this is to graph the function down here, 1 half x to the third minus y to the third plus 4xy. And before I graph that, I just wanted to go ahead and change the viewing window so the whole function could be visible. So I just made the minimums on the x, y, and z axis -5, and the max is 5. Just so we can have a nice even viewing axis, right? Viewing window right here. So this is our graph of the function. Right here, as you can see, it's kind of a funky shape, as you can see. But this is our function, our surface, once we graph out that function that we were given. And the next thing we need to do is make a contour plot of this. And in CalPlot 3D, all you need to do is you need to click this button right here, and these are the values that I set. So we needed at least six different curves. Chose 10, we're gonna have 11 curves. We're going to start at our first level value, which is -50, and going to 50. These are just going to be our z values right here. These values are going to show up when we create the plot. Let's go ahead and make the plot. So as you can see, each curve is labeled with its respective z value right here, as you can see. And one interesting thing about this contour plot is that there's this saddle point right here at the origin, because you can see that this contour goes around and then intersects with itself again. And so this is a saddle point right here, which means that the point 0, 0 is a critical point with this function right here. And then because it is a cubic function, you can't really see it too well down here, but up here, there's some really rapid growth going on because the function increases drastically as it increases and decreases drastically as those x and y values decrease as well. And so that's the contour plot of this function. And then after that, we are tasked with graphing the tangent plane of this function right here at the point 2, -1, -3. So here's the math for that right here. You just take the function and then you find the partial x and y derivatives. So partial x derivative is this right here, and then you just got to plug in whatever points you're given. And so the partial derivative of f of x at this point 2, -1, -3 is 2, and the partial y derivative at this point is 5 right here. So then what you do is you take these 2 points, you plug them into your plane equation, and then this z value right here actually is supposed to, it's not shown, but this would be on the other side of the equal sign, and then you got to move it over to this side so you can find the full function. But that's just implicit here, not explicitly written out. And so after you solve all of that, you FOIL everything out, you get this right here, and then you just go ahead and you combine your values and simplify. So the plane you find is going to be f of xy is 2x plus 5y minus 2, and that's our tangent plane right there. Let's go ahead and plot that out. As you can see, this plane, see if I can rotate it, the plane pretty tangent to this point. So 2 is right here. If we go down here, you can see that we are at 2, -1, 3 right there. It's a little hard to get a good angle so you can see perfectly, but you see the intersection right there. And this plane is tangent to that point, 2, -1, -3 at this point right here. And if you also just want to look at the contours, you could also do that as well. As you can see, there we go. See that intersection right there. So this plane is tangent to our original function.